So this brings us to the last lesson of this unit, which is density. And density is the relationship of mass to volume. It can be thought of as a concentration of matter. So the more dense something is, the more concentrated the matter is. The formula for density is equal to mass over volume. And oftentimes we'll just do m over v. The units for density are going to be different depending on whether you have solid, liquids, or gas. For solids, we're going to be writing them as grams per centimeter cubed. And the reason we use centimeter cubed, because remember when we're doing volume for a solid, it would be length times width times height. So that is where that centimeter cubed comes from. For liquids, we would be doing grams per milliliter. And then for gases, it's going to be grams per liter because gases are not very dense. So if we kept it in milliliters, it'd be really, really small numbers with lots of zeros in front. So we do grams per liter, okay? Those are things that you have to just memorize what they are for each one. The other thing that I need to make sure you memorize is that the density of water is 1 gram per milliliter, okay? 1 gram per milliliter, which means if I have a gram of water, if I have a gram of water, it'd be 1 milliliter of volume. Or if I had a milliliter of water, it's going to be 1 gram, because we're going to be able to use density as our conversion factors. You'll do that in practice, but you'll also do that on the take-home lab that you're going to do. So let's look at how to calculate density. So in this case, we have two boxes. Remember, we said density can be thought of as a concentration of matter. So we want to know which box is more dense. It's not a trick question. It literally is the one that has more particles per the same amount of volume, which would be that one. So that particular sample would have a higher density because there's more particles or more mass per volume. Density of liquids, remember we said you have to memorize that density of water is 1 gram per milliliter, and so if you have less than 1 gram per milliliter, it's going to float, and if you have greater than 1 gram per milliliter, then of course it's going to sink. And so this is an example of oil and water. The density of oil is 0.95, so the oil layer floats on top of the water layer. Okay, if it's the just slightly smaller than water, it might stay suspended in it, kind of like ice does, because ice is just slightly less dense than water, so it kind of stays partially in there. So remember to memorize water. And then when we're calculating density, you want to find out how many grams you have, or the mass. You want to determine the total volume that your mass occupies, and you're going to divide the two numbers and report the answer in the correct units, depending on if you have a solid, liquid, or gas. So here we have an example that we're going to do. It says an unknown metal having a mass of 287.8 was added to a graduated cylinder that contained 31.47 milliliters of water. After the addition of the metal, the water level rose to 58.85. Calculate the density of the metal. This is a method known as water displacement, and this is going to be how you're doing your virtual lab. So for irregular objects, we can't just do length times width times height. So we use a method called water displacement, because when we put the metal into the water, it displaces or pushes some of the water out of the way. So the difference in these two volumes will be the volume of our sample. So we're going to figure that first out. We're going to take volume, and we're going to say 58.85 minus 31.47, and we're going to get that it is 27.38 milliliters. So that is our volume of metal, because that's how much water was displaced. It gave us grams right here, so now we can simply stick it in and do mass over volume. Plug in our numbers in. We have 287.8 grams divided by 27.38 milliliters. And our answer into 4 significant figures, because both values have 4 significant figures, would be 10.51 grams per. It should be grams per milliliter because that's what we calculated, but because we know it's a solid, we would go ahead and change that to say, okay, we know this is a solid, so it would be grams per centimeter cubed. Recalling from the beginning of the unit that 1 centimeter cubed is equal to 1 milliliter. That's why we can just change those units. So let's practice this problem. The density of mercury is 13.6 grams per liter. How many grams would 1 liter occupy? So this is where we're going to use density as a conversion factor. So we're going to start with the 1 liter, and we're going to say 1.00 liter. We want to cancel out liters, so my density has units of grams per milliliter, so we're going to say 13.6 grams per liter. So then my liters cancel out, and then that means I would get 13.6 grams of mercury. So that would be my answer. The next one is a solid with dimensions of 3 times 4 times 2 centimeters. Each has a mass of 28 grams. Will this solid float in water? And then, of course, it's reminding us that the density of water is 1. We would have to calculate our density and see if it's greater or less than 1. So the fact that it gave us volume right here, or it gives us length times width times height, so we're going to say 3 times 4 times 2, and that is going to give us a volume of, excuse me, 24, and remember that's centimeters cubed. Okay, so now we're going to do our density and say density is equal to mass over volume. So we're going to say 28 grams divided by 24 centimeters cubed, and that's going to give us 1.2 grams per centimeter cubed. And remember, milliliters is the same thing as centimeters cubed. So the density of water is 1 gram per centimeter cubed, so this would in fact sink because it is heavier than water, or has more dense than water. Okay? And let's do one last example. This says a gas has a density of 0.824 grams per liter and occupies a volume of 3 liters. What does that weigh, or what is its mass? So always start with the 3 liters, with what's given or what we know, and we want to get rid of liters. So we're going to say 0.824 grams per 1 liter. So we're going to